Awesome. Well, yeah, thank you very much for the opportunity to come chat about some things and show some pictures and talk a little bit about the ongoing research, which I had to struggle a bit to figure out what exactly to talk about because there's, as you all are all aware of, so many things going on and so many interesting things and interesting yet troubling, yet also problems that provide us with plenty of opportunities to work towards a better ultimate outcome. So despite talking about a lot of maybe less exciting or, well, very exciting, but less positive things, we'll start off with a very nice photograph that I took earlier this year from the Annandale State Park region, where we kind of had all the nice weather happening at the same time. We had mountain waves and we had lupins blooming and we had forests were looking pretty good for the most part. And it was just a really fantastic day that shows that there is still wonderful things going on despite ongoing drought conditions. So despite drought, you can still have some nice things taking place. But so let's talk about the drought. And now we're in a new drought. If you decide to terminate and start droughts based on, there's all kinds of different definitions. I'm just going to sort of use the drought monitor as kind of a basic one here. So we've always gone in and out of drought in California. That's something we're all very, very familiar with. And we had hoped, I think, that we were sort of out of a pretty bad one. The sort of mid-century or mid-teens drought. I don't have very cute names for the recent droughts. So always interested to take feedback on what those are called. I like to call the late 1980s to early 1990s drought the Nickelodeon drought, because that was what I was doing during those drought conditions, was watching Nickelodeon. So here we'll just talk about the penultimate drought, the second to last one, and then our ongoing drought, which really started in 2020 when we had pretty dry conditions overall. And I think 2021 really led to an exacerbation of that thanks to dry conditions, anomalously warm conditions, and notably very thirsty atmospheric conditions. So as the atmosphere becomes increasingly dry, it becomes thirstier, and there's a greater vapor pressure deficit that pulls what little moisture we have out of the soils and out of the plants, kicking off all kinds of different feedbacks that can exacerbate drought. 2022, we were off to a good start, and we thought we were going to make some pretty good gains with a big storm in October, and then a very record wet and snowy December. But then, as we'll talk a little bit about, and we went into a pretty nasty midwinter dry spell that really brought us backwards a bit. And ever since then, we did have some other amelioration in late spring this year. We had a really nice set of storms in April that kind of kept the snow around and improved the skiing and sort of offset fire season by a little bit in certain parts of the state. But by and large, we've kind of crept back into increasingly severe drought. And so statewide, we're not looking as bad as we were in the penultimate drought, but speaking for myself and anecdotally from discussions, this one feels worse for a number of reasons. It just feels a little bit more extreme, and maybe we're seeing some of these more decadal scale legacy effects really taking place. We've never really recovered groundwater wise, as an example. And I expect this is the drought monitor from September 6th. I anticipate that this will probably, we're going to see some more dark colors, darkening of the colors on this map in a couple weeks when the new one comes out, thanks largely due to the recent heat wave, although in far Southern California, thanks to the very anomalous tropical storm, our hurricane remnants from Hurricane K, we should see some, hopefully some improvement there, with places receiving on the order of 2 to 5 inches of very out of season heavy precipitation. So we'll take a few looks from space and from cameras, but first I want to start off with a little bit of art that I thought was really a fantastic thing that was created by an artist a couple years ago at a California EPA meeting after a few of us gave some talks discussing California's changing climate. And a big theme of the session was both extreme events, but then also the timescales that they span. And so as we talk about weather and climate, I think it's really important to always think about what time scales are taking place and what spatial scales are taking place, and how do all of those interact together. And so I think it's a nice thing to think about, that we're really talking between seconds, which we can think about the onset of strong winds or the ignition of a wildfire from a lightning strike or some other human-caused way, moving into days or months, where we start thinking about precipitation for riverine flooding or degraded air quality, moving into more longer terms, years, where we think about drought and persistent drought, and then even moving up to millennia, where we think about how these finer scale processes integrated over time really shape the landforms that we live upon and work amongst. And then just think about the processes that are taking place and how big of a spatial area those are occurring. And we're in this unique time where we have both concurrent events all happening at the same time or following one another sequentially, and that poses all kinds of problems, as I'm sure you are all very well familiar with. And if you're not, you probably will be soon enough. And kind of a starting thought, something that we've been thinking a lot about is, with what's going on, is what we're seeing is really not surprising. It's been very well forecast and generally well understood. These are all expected environmental changes with impacts on society. And our models have done a remarkably good job at doing this for decades now. Not to say that we have not been continuously improving our confidence and the nuance in terms of getting more precise with the kinds of impacts or the locations that they'll take place, and further constraining other challenges in models to make us a little bit more confident in the results. But I think really the surprising aspect is the rate at which changes are taking place. For the most part, we got the what, and we did a really awesome job at that. But I think we've struggled at the when, and there's maybe a few reasons for that. One could be the blind spot issue with models. Models are, they're all wrong, but some are useful, and we can't correctly represent an extraordinarily and impressively complex system with models. So we're always going to miss certain things that can trigger these cascading sequences in natural systems. And then I also feel like we might have focused a little bit too much on sort of what we call the deep or late century. And we always sort of thought about change in terms of by 2070, by the late century, by 2099, and maybe forgot that some of these problems could occur sooner than that. So I think that's a couple reasons that this is a little bit, maybe a little bit more surprising, and some stuff to kind of think about as you go forward. So let's look at some pictures of some of our stunning events. This is about this time last year. Many of you are familiar with the Caldor Fire in the El Dorado County region that caused all kinds of challenges and troubles. And now we're seeing another part of this watershed, or not the El Dorado watershed per se, but the American River watershed is now burning on the far left-hand side of the image. And you can see both the, if you can see my cursor here, the American fire scar and the King fire scar. Now we have a lot of fire activity in this region now, unfortunately, also producing very poor air quality impacts in this same region. Moving forward to October, here is our Category 5 atmospheric river that brought very notable precipitation, some daily records in places, and a lot of locations receiving daily precipitation extremes on the order of a 1 in 500 year event or upwards of 1 in 1,000 year events. So a little bit of flooding, probably largely mitigated by the extremely dry soils preceding the year. But I think this event really did help set us up for a little bit more of a productive runoff generation year by putting down on the order of 5 to 15 inches of precipitation through a very wet period to end October and start off in November. However, despite the great start to the year and a really fantastic December, that midwinter dry spell that I had mentioned really took its toll on our snowpack. And so by our historical peak timing of snow in late March, early April, we were pretty far in the hole as far as snowpack expectations were going. We were well behind schedule thanks to a lack of accumulation. So this is a blended product from using NASA satellites and models to estimate the percent of average snow water equivalent over the greater Sierra Nevada and Southern Cascade regions. And you can see on the chart on the right-hand side that little bit of improvement that we did see in mid to late April really benefited us. I think we would have been pretty much done by mid-April had that not taken place. And instead that really extended the snow season by a solid 1 to 2 months in different locations. Extreme precipitation befell Death Valley this summer. 2 satellite images showing kind of before and after images of the 1.46 inches of rain, which is really close to the all-time record there at Furnace Creek. Lots of flooding, lots of fan alluviation and movement of debris. People were stranded. It was a very challenging event that really kind of highlighted these extreme precipitation events still can happen even in the dry season in these monsoon favored climates and wreak havoc on things. And the number of people that were trapped kind of also highlighted to me the challenges with forecasting these kinds of events and communicating to people these natural hazards are still present and how to deal with them appropriately. Then going back to this mosquito fire that we had alluded to in one of the prior slides, this was, I thought, a fairly stunning photograph about a week ago when the fire activity was extremely extreme. Plume-dominated behavior right at sunset with clear upstream conditions, so allowing for the final rays of light to really create this pretty stunning view from looking north from the Bald Mountain camera. And then we're not done yet. This is just we're getting there, but this is just earlier, a couple days later. You can see Hurricane K in the almost making landfall, kind of moving up the Baja California coast, bringing very warm, juicy tropical air into the region, contributing to heavy precipitation in San Diego and San Bernardino counties. Meanwhile, we had just exited this extraordinary heat wave where we were seeing temperature anomalies on the order of 30+ degrees Fahrenheit in the North Bay region, Napa, Healdsburg, Santa Rosa, and several other locations found daily temperature anomalies on the order of greater than 30 degrees Fahrenheit, which is pretty substantial. And then there were just absolute shocking numbers of widespread triple digit and 110+ degree temperatures for many days on end, which was the persistence was quite notable about this. So all the events kind of happening all at once. But let's move to a little bit longer time scale problem now. Something we're seeing in the northern Sacramento Valley is sort of this east-west difference in terms of crop activity, as seen from Landsat. The normalized difference vegetation index highlights the fallow fields on the west side of the valley, which is receiving its water from the federal project and Sacramento River. Many fallowed rice fields in that neck of the woods, thanks to extremely low flows on the Sacramento River. Cumulative stream flow is shown on the right-hand side, and the black line is our current observation of cumulative stream flow. We're not as bad as 1977, which is our record low, but we are certainly in the bottom 25th percentile, and I would guess we're probably well within the lower 15th, maybe even the lowest 10th percentile. That 97 event is, or sorry, 77 event is quite notable in terms of its dryness. 97 was notable in terms of its flood event that took place. That might be one of the higher lines. But then on the right-hand side, the eastern side of the valley, receiving state water, folks are doing quite a bit better there. So there is this regional difference despite widespread drought conditions overall. So I made a brief table of just a few example expectations of a warming climate during our ongoing drought. By no means is comprehensive. This is just sort of putting down some thoughts of things that we're seeing when they're happening. If you have additions to this, those are more than welcome. Or if you find this useful, let me know and feel free to take a screenshot, or I can send it to you if you'd like. So we are seeing extreme precipitation kind of in 2 time scales. are short duration, high intensity. This year, we've had a number of short duration, high intensity precipitation events that have led to localized flash flooding, urban flooding, and post-fire debris flows, some of which are occurring in places we haven't seen them previously. So that's offering an interesting research opportunity. We are seeing extreme storm precipitation, so sort of longer term, multi-day or daily totals. Here, we're really thinking about this Hurricane K event, Death Valley event, and then October and December precipitation in the northern part of the state. All 3 years have experienced low to no snow conditions where we've seen persistent episodes of snowpack being in the lower 30th or even lower percentiles, whether that's at some point during the year or at the time of peak snowpack is up to the person using the definition, but we like to think about these anomalously low snow conditions. Depending when they happen, they all have different impacts, whether it's water resources or tourism or vegetation and ecosystem health. Low stream flows, we've been seeing the last couple of years as sort of a longer term cumulative effect. I don't think 2020 was as bad because there was still a little bit of base flow left over from the relatively wet 2019 season, but the low stream flow has largely been a product of the ongoing low soil moisture, which has also led to some hydrologic forecasting problems throughout regions of the state. In terms of thinking about fire, maybe I should have put heat before fire here, but we're seeing extraordinarily receptive fuels through various wildfire metrics in essentially all years, and that is contributing to extreme fire behavior that we've continuously observed in each of these years during the ongoing drought. Widespread extreme heat, also seeing a lot of that statewide and in particular regions over and over, particularly 2020 and 2022. And then I'm aware of an event this year, but not as much in prior years, because I haven't looked. But I did hear a lot of discussion about the late season cold snap this year that was causing some challenges for several agricultural producers. Some very close to Davis, a friend who has a farm in Winters was thinking about making the big investment for a system to keep the cold air mixed out and whether or not he would need to do that. So we're kind of seeing all the expectations of a warming climate, extremes on either end becoming more frequent, more persistent, and more intense. And it's not just a California problem. This is a West-wide problem. And so we rely on a lot of water from the Colorado River, who is also undergoing an increasingly severe drought. Looking through the metric of SPEI, we're seeing kind of a trend towards more extremely to exceptionally dry conditions. Also expected, but maybe not expected to be taking place at this current, maybe as early as we're starting to see it, but it's here, now we get to deal with it. And so I think kind of from this, you cruise around on your bike, in your car, on the plane, however you get around with your shoes. Any given working land is increasingly exposed to a growing suite of hazards, whether it's wildfire, cold snap, air pollution, farm worker, heat, health, public health impacts. There's just so many hazards, water availability, so many hazards that are being sort of compounded upon us all at once. And so I think it's important to really think about how all of these are interplaying together as we think about moving forwards in terms of prioritizing our adaptation and mitigation strategies. So with that all set up, let's talk a bit about snow, which is kind of one of my favorite things to go wander around, look at snow, slide on snow, poke around, carry a backpack with all your toys, bring the students out and see what's going on, because our snow is very vital and societally relevant and spiritually relevant to many of us. And it is changing, and it is changing quickly. And the historical declines in snowpack are very well established, product of a warming environment, a transition from snowfall to rain, less frequent snowfall events in certain parts of the country, more frequent rainfall events. When we do get big storms, as the snow level increases, we get a increasingly small area that is able to receive snow. And the net effect of that is a decline in our historical timing of peak snow west-wide. Picture on the right shows a spot along Highway 88, the road to Kirkwood, at about 7,500 feet, right around peak snow time. And if you told me that was October 5th, I would have believed you. If you told me that was June 17th, I would have believed you. If you told me that was going to be March 27th, I would kind of laugh and say probably not. But there we are. Very, very, very low peak SWE at many elevations throughout the Sierra Nevada this year, owing to largely that persistent dry spell that did not allow snow to accumulate as it normally did during the winter. Continued snowpack declines are very well projected, robustly projected going forwards in the 21st century, especially later in the century. So we really start to get concerned beyond about 2070, 2075. Region by region, the timing does vary. And so the figures on the left show kind of this consistent decrease Western US wide, whereas the Cascades in Sierra Nevada kind of undergo this continuous change compared to the higher, characteristically higher and colder, more intermountain regions of the Rockies and the Wasatch and Uinta ranges, where it takes a bit more warming to really make an impact on those areas. And if we start applying this low to no snow threshold, this below 30th percentile threshold, throughout not just the Western United States, but the entire American Cordillera, we see this emergence of low to no snow conditions taking place persistently in the middle of the 21st century, starting roughly around 2050. And it is earlier in the Southern Hemisphere. And I think Chile offers a really fantastic comparison for us to look at in terms of what's happening there with all of the various impacts of snowpack loss, because they're ahead of schedule, both in terms of the schedule we're on and in terms of expectation. So we will see this notable decline in snowpack continue to accelerate. And so now is the time to think about what happened to us during our low snow years. How did we deal with that? What worked? What didn't work? Because we're moving increasingly forwards towards that. Something else that we expect to see with this declining snowpack is a change in the snowpack behavior itself. Using a projected 20-year worst case drought from the fourth climate assessment, I did a little analysis at looking at the snow seasonality, so how long that snow is persistent on the ground, and that plays into several other interesting aspects of snowpack. Seasonal snowpacks tend to be colder, they're persistent, they insulate the ground and roots from colder atmospheric temperatures. And in a warming and drying world, we expect to transition from seasonal snowpacks to ephemeral snowpacks that are warmer, easier to melt. They come and go with storms. And under those conditions, we see about an 81% loss of seasonal snowpacks throughout the California, Southern Oregon, and Nevada regions. And so basically anywhere on that right-hand figure, you see dark red. Those were seasonal snowpacks historically that are now becoming much less season, or they're now ephemeral snowpacks, with a lot of snowpacks becoming less seasonal. Devin, you just popped on. Am I running out of time?
Yeah, I'm so sorry to interrupt. I do just want to say that this meeting is over in 2 minutes.
Okay.
And I want to be respectful of everyone's time. Yes. And I'd love to open the floor for questions. I know you're not done with your presentation yet.
No, let's leave it right there, because it's a perfect ending point.
Okay, great. I'm so sorry to interrupt, but
no problem.
Great. Well, then with that being said, thank you, Ben. And would anyone like to ask questions?
Yeah, I'll ask a quick question. Ben, we have this La Nina that they're saying is setting up for this winter. And so could you just share with the group a little bit about what that might mean for the upcoming winter snowpack? We're in year 3 of a drought. If we get another year of low snow, we're looking at, another 4th year of a drought potentially next year. So what might the La Nina forecast, and particularly this triple dip La Nina, mean for us?
Yeah, so that's an excellent question, because that's on the mind of pretty much everyone now, is, are we going to get out of this? And the way I like to think of La Nina is it largely stacks the deck against us, but that's not to say that it precludes us from having a wet year. La Niñas can be very wet. We had weak La Niña, or maybe it was strong La Niña conditions in 2011. That was a very wet year. And we had, I think, briefly some stronger La Niña conditions in 2017, which also brought us quite a wet season. But I think statistically, the central Sierra Nevada is somewhat indifferent to La Nina, although the big challenge is as SST patterns change and global circulations change with warming, these historical relationships aren't quite as strong. And so I think while it doesn't preclude us from having a good winter, I would say it does edge us towards likely to have another drier than normal conditions. The triple dip concept, I don't know if I'm not an oceanographer per se, but it's such a new phenomenon. I don't know if anyone really knows what to expect, because I don't think we've really seen one of those before. So that's maybe another kind of new emergent, oh, this is sort of an interesting thing. I wonder what this might do. And so I would say keep your eyes out, because some folks might be doing some really interesting kind of quick model simulations to sort of see what that might do. And that's one way we get a lot better at our ocean atmosphere seasonal forecasting, is to start playing with these kinds of questions. But yeah, I would say probably not looking great for an extremely wet winter, but we still have a little bit of a chance.
Great. Gabrielle, you have your hand raised.
Yeah, two questions. One is sort of following on with the image that's still there, where you see less snowpack. Do you see a similar amount of, do you see changes in the amount of precipitation, or just the, and just a change in the type of precipitation, or do you see less or more water or rainfall with the modeling? That's question one. And then I have another question.
Cool. Yeah, that's a great question. So with this particular model simulation that we use, we picked, and what Dave Pierce and co-authors picked in the fourth assessment, basically the driest 20-year period from whichever model had the driest 20-year period in the 21st century. So this is kind of a worst case situation, because it has some level of warming, but it's also the driest simulation. So in this case, this is a very precipitation driven outcome of we're getting less snow and more rain. And then of whatever precipitation we get, we're scaling that back by a pretty substantial amount. I think the precipitation anomaly here is about 77% of the historical average.
Wow.
But many of the future projections suggest not a lot of change in average precipitation for California, but there is there's my timer, sorry. But there is a pretty robust projection that how that precipitation comes will be in fewer and larger, so more extreme events, and that we'll also see this background warming taking place on top of it.
Yeah, okay, I just was curious, because that's sort of what I've been hearing was more wetter episodes like what we had in December, and then the rain, that kind of thing. And so how do you set up the infrastructure to meet that? And then my other question is just simply, with all the efforts to try and slow climate change, maybe wishful thinking, do you see, how much change would we need to make in our greenhouse gases to actually still influence what you're seeing?
Let's see. I think it would be a substantial amount. I don't have a magic number. And I know there's a lot of folks who are trying to come up on, what level of target emissions do we need to hit? I would estimate that it's probably a pretty non-negligible large number.
Yeah.
Maybe pushing 30 to 50%. I probably should know that number, so I apologize for not knowing that piece. But yeah, I think it's going to be a pretty, any improvement or even a slowing of emissions is good at this point, but it is really critical that we get eventually, and the sooner the better, get to zero emissions, if not net negative, because as soon as we can stop emitting, we're going to slow the rate of changes. And then as soon as
Right.
we become negative, then we can slowly start kind of working our ways backwards in terms of some of these extreme events. But many systems like, the storage of ice in the cryosphere, that takes a very long time to sort of recover. But it will leave the people who are out there in 100, 200 years in a much, much, much better place, the decisions that we make in the next 10 to 20 years.
Thanks.
So I am just looking at the clock and we are a couple minutes over. I put something in the chat that I'll send out the recording for those who have to head out or have meetings right now. I'd just like to say, does anyone else have any questions as we're just finishing up?
That's great. Thanks, Ben.
Yeah, thanks, Ben. I completely lost track of time, so I was completely unaware of what. And I'll just say for the record, I knew you were doing this, but I bought my ski pass already.
That's good. You should always buy a ski pass.
Agreed. But no, this is a continued conversation. I think it's really timely to have this, right? We kind of saw where we were after 3 years of this, both in the agricultural, especially crop industry, but also with where we ended up in the forestry space, right? And now as we're entering, without full recovery from that period, as we're entering a 4th year potentially, right? There's some, I think, important conversations to be had amongst individuals on this call and beyond. So I really appreciate you taking the time to do this. It's really, really important. Thank you.
Yeah, no problem. And I can totally send along the full PowerPoint because I got too excited about the ongoing stuff and then the research. So there's more to come.
Yes, Ben, if you could please send that to myself and Devin, that would be appreciated. Thanks.
Okay, awesome.
Great. Well, with that, I will just say thank you to everyone who has joined today and has provided updates, and thank you to Ben specifically and to all of our partners. And as always, if you have anything that you would like to share with the Hub, feel free to reach out to Steve or myself or Lauren or any of us, and we'd be happy to collaborate or help out in any way we can. So with that, I'll let you all go. Have a great rest of your day, and I'll stay on
Thanks,
for
everyone.
a minute or two if anyone needs.